Hi there. Let's talk about some cool stuff students have seen in math class. This did not happen to me. This happened to a colleague of mine, but it was cool enough that my colleague came over to my room to tell me about this observation that the student had made. Now, if you've studied transformations, you might remember this. When you're doing transformations, you have a parent function, in this case, y equals the absolute value of x, which here is graphed in black, and then a transformed function, y is equal to the absolute value of x plus 2, which here is graphed in red. And when you study transformations, you learn that when transforming functions, adding a 2 inside the function slides the graph 2 units left on the coordinate plane. In other words, the second function is obtained by taking the first function and sliding it left. We'll then introduce absolute value equations. So the student had already studied transformations, and now they were talking in class about solving the equations. And the student noticed that there seemed to be a connection between the parent graph and the simple equation, x, the absolute value of x equals 5, and the transformed function and this variation on the equation, the absolute value of x plus 2 equals 5. So what the student wanted to know is, can we solve the second equation, the one that's a little bit more complicated, by simply sliding the solutions to the first one 2 units left on the number line? Instead of going through the algebraic process and engaging the definition of absolute value, could we just get the solution by transforming on the number line? So the first equation has the solutions x is equal to 5 and x is equal to -5. So the distance from 0 is 5, so that could put the solutions to the first equation at 5 and -5. Can we get the solutions to the second equation by just taking those solutions and sliding them left 2 units? So would that be -7 and +3? And it turns out, why, yes, it is -7 and +3, and you can get there without doing the algebraic work of splitting up the equations. It also ties in information from another piece of absolute value and makes it make a little bit more sense why that transformation is to the left, even though you're adding a 2 and it feels like it shouldn't be. Always share your thoughts and insights, because you can observe stuff that maybe your teachers have never seen, and they might just be talking about it years after you bring it up in math class.